All right, everybody. So what's going on? We're going to do weathering and erosion review, starting with question number one. So it says the map below shows the top view of a meandering stream, right? So it's a stream that has curves as it enters a lake. And it says at which point along the stream are erosion and deposition dominant, all right? So one of the things that we've learned, locations that are on the outside of a meandering stream, right? That means that there is more erosion taking place. So the outside of the curve, right, where B and C is, there is more erosion taking place. All right. When you're on the inside of the curve, like A, right? Change the color. Like A, there's more deposition. There is more deposition taking place. The other thing where there's also more deposition is at D. Now you may be wondering, why is there more deposition at D? It's because when a stream enters into a lake, the stream slows down. And so when the stream slows down, you got to remember deposition is going to occur. That's why there's more deposition occurring at A and D, and there is more erosion occurring at B and C. And so the correct answer is choice B. All right, number two. Number two, it says based on the answers to the following question on the diagram below, which represents four samples of equal density sediments being carried by a stream. Sorry. All right. And then it says which sample would be deposited first as the stream velocity decreases. So once your stream velocity begins to decrease, the rule is that the bigger particles get dropped off first. The bigger particles are deposited first. They deposit first. They get dropped off first. All right. The stream is not moving fast enough to carry the largest of sediments, and so therefore that's why it has to be dropped off first. So which is the biggest sediment here that's going to be dropped off first? It is going to be option D. All right, number three. So number three says a stream is carrying sediment particles ranging from 0.0004 to 25.6 centimeters. Sorry. When the stream velocity decreases from 300 to 100 centimeters per second, the stream will most probably deposit what? Well, what page of the reference tables are we able to see what sediments can be transported by stream? We're looking at page 6. All right, so when we go to page 6, we see, let me just zoom a little bit out. Here we go. Right, and we see this diagram is what we're going to be focusing on. So one thing I do know is that when the stream was moving 300 centimeters per second, right? So if this is 100, each line here is going to be going up by 100. So 300 is here, all right? And I know my line's not straight, but I do know at that point it's 300 centimeters per second, which lets me know I can carry everything, right? The black line is not even being touched, which lets me know I can carry everything. Now, when I then go to 100 centimeters per second, right, I can still carry clay, silt, sand, and some pebbles. So I can still carry clay, still carry silt, still carry sand, but now I can only carry some pebbles. Some pebbles now. All right. So what can I not carry anymore. Well, when I went from 300 to 100, right, I lost, and let me put a different color right here. I lost this area right here that I'm shading in, right? That's how much it decreased. I lost this area right here, all right? And so because of that, that means I can't carry boulders anymore. I can't carry cobbles anymore. And there's only some there's only some pebbles that I can carry. There's only some pebbles that I can carry, right? So that's why my correct answer in this case is going to be choice D, cobbles and pebbles. Cobbles and pebbles. All right, so number 4 says, base the answer to the following questions on the graph below, which shows the average yearly temperature and average yearly precipitation for Earth through locations A through E. All right. So it says, which location has the climate conditions necessary for the greatest amount of chemical weathering to occur? The key thing we're going to be focusing on is chemical weathering, right? And as we've learned, the greatest amount of chemical weathering occurs in a warm and moist climate. A warm and moist climate is going to give you the greatest amount of chemical weathering. So which letter is the warmest, right? It's definitely going to be either C, D, or E, right? Because the average yearly temperature, it increases as you move to the right. And where am I going to get the most moist climate is going to be when my average yearly precipitation is the highest. So I'm looking for an area that is the warmest, and I'm looking for the letter that'll let me know, hey, this is going to be a very wet climate. So the average yearly precipitation is going to be high. The one that's the warmest and the precipitation is the highest is going to be choice D. That's why your correct answer is choice D. All right, number 5, base the answer to the following question on your knowledge of earth science, the earth science reference tables, and the diagram below, which represents a cross-section of the Earth's crust. Rock layer B appears to be. So B, I'm focusing on B, is right here. All right. So a question like this, sometimes you may even want to just do the process of elimination, right? So when it says B is the result of an igneous extrusion, right? I don't see any sort of rock or rock layer that is cutting into B, right? So there's not anything cutting into B. So that's why there's no extrusion that is taking place, right? That's the first thing. The second thing I'm looking at, all right, rock layer B appears to be younger than residual soil X. It can't be that either, because if it was younger, then that means that rock layer B would be on top of the soil. Instead, soil X, which we see right here, is on top of B. So that lets me know that it's younger. All right, whatever's on top, generally speaking, is going to be younger. Now, when I'm looking, it says made of a different material than rock layer G. When I look at the symbol of B, right, which is, it looks like bricks, I look at the symbol for G and I see the same symbol. I see the same symbol. It looks like bricks. So that lets me know B and G is actually made up of the same material. And when I look at, so my correct answer is C, more resistant to weathering than rock layer C. That makes sense because doesn't it look like rock layer C got cut off more, right, than compared to rock layer B, right? There's more of rock layer B, especially that's higher, compared to rock layer C, right? That is lower. So that's why we can say B is more resistant to weathering, right? The word more resistant to weathering just means it's much more difficult to break this rock layer down. So there's going to be more of it standing. And that's why the correct answer is choice C. All right, so number 6 says, base the answers to the following question on the diagram below, which represents the landscape features associated with our meandering river. Letters what W, X, Y, and Z represent locations on the floodplain. And so the question says the choices below represent stages in the form of a meandering river. Which sequence best represents the usual changes over time? All right. Remember the lesson that we talked about, right? What can be recognized as an old stream and what can be recognized as a young stream. And for sure, when you see a stream that is curving more, right? There's more curves, there's more meanders, right? One characteristic you're going to see is that there is more meanders, right? More meanders, right? There's definitely more curving taking place. All right, that's going to give you an older stream. All right. And so when I'm looking at my options, right? I'm basically looking, they want to know which sequence best represents the usual changes over time. So this question is basically asking me, what does a stream look like from young to old? Right? This question is basically asking me which one shows the correct sequence for going from young to old. And so when I'm looking, all right, I already know I can definitely cross out C and D. Why? Because, sorry, at C, right? Right here, I'm already starting off. With meanders, right? And is working backwards. So they want you to go from young to old, okay? And I'm looking at B, and we know that C right here, this should show the oldest time frame. This should show the oldest representation because that's when we have a lot more curving taking place. And that's why the correct answer in this case is going to be, oops, let me move this other stuff out the way. All right. That's why the correct answer is going to be choice A. Because you start off with a somewhat of a straight stream that represents that is young, right? And eventually, the older that a stream gets, the more meanders that you get, which is shown right here. And that's why A is the correct answer. All right, number 7. Which quartz sample has probably undergone abrasion in a stream for the longest period of time? So one of the characteristics for a rock or any sort of material that's in a stream for longest period of time is definitely going to be rounder, right? It's definitely going to be rounder and smaller in size. And the key characteristic is rounder. So the fact that I'm looking for a material that is in the stream for the longest period of time, I'm looking for an object that is very round. And out of A, B, C, and D, the one that looks like that has the roundest shape is going to be A. And this rule only applies if you have a particle in a stream or river for a long period of time. All right. All right, number 8. Number 8 says a stream flowing, there you go, at a velocity of 250 centimeters per second is transporting sediments, particles ranging in size from clay to cobbles. Which transported particles will be deposited by the stream if its velocity decreases to 100 centimeters per second? So you're starting off with 250 centimeters per second, and you're ending up at 100 centimeters per second, and you're looking only, this is why we got to read, we want to know only the particles that will be deposited. All right, so what we're going to turn to, we're going to turn to page 6 of our reference tables. All right, and at this point, I'm going to go to 250. And when I see 250, 250 looks to be somewhere down the middle, right? And at 250, I kind of see it crosses the black line around here. So we know at this point, at 250, right? At 250 centimeters per second, you can carry boulders, cobbles, pebbles, sand, silt, and clay. Now, when you go to 100, right? When you go to 100, and let me just zoom out just a little bit right there. When I go to 100 centimeters per second, right, and I follow this line until I hit that black bold line, and it stops right here. So that means I can still carry clay, silt, sand, and only some pebbles I can still carry at 100. So what can I not carry anymore? I can't carry boulders, I can't carry cobbles, and I can't carry some pebbles, right? There are some pebbles who have a higher diameter than at this point. I cannot carry some pebbles, right? Some pebbles I can't carry, right? That has this level of diameter. All right, so that's why. So boulders, cobbles, and some pebbles I can't carry. So when I go back to my answer sheet, let's see. It's definitely looking like, right? Boulders, cobbles, and some pebbles. The best answer definitely looks to be choice B. There we go. Choice B. Number nine says the demonstration shown in the diagram below indicates that powdered limestone reacts faster than a single large piece of limestone of equal mass when both are placed in acid. So we have a one solid material of limestone, and then we have 10 grams of limestone, but it's powdered, right? It's broken up into the point where it's powdered. And you drop them both in acid. Now the question says the most likely reason powdered limestone reacts faster is that it has what? Well, when you break something up into many little pieces, all right, there is something that you're doing that we learned in class. When you're breaking something up into many different pieces, right? Many different pieces, you are actually increasing, the surface area. You're increasing the surface area. All right, that's why the powdered limestone is going to break down faster than the rock limestone. And that's why, because that's a more total surface area, which is choice C. Number 10 says a cross section below shows a V-shaped valley and the bedrock beneath the valley. Which agent of erosion is responsible for cutting most V-shaped valleys into bedrock? Well, as we learned, V-shaped valleys are created by streams or rivers, right? Which is an example of running water, not ocean waves, running water. All right, V-shaped valleys are created by streams or rivers, which are examples of running water. All right, number 11. Number 11 says a decrease in a river's velocity will most likely result in more what? As we said this before, when a river or stream, right, slows down, as soon as it begins to slow down, we know that deposition occurs. Deposition occurs. This is a known fact. When a river or stream slows down, right, when it's entering into a lake, for example, immediately deposition occurs. And that's why the correct answer is choice B. So number 12 says the sequence of diagrams below represent three stages in the formation of a geologic feature over time. So we have ice, right? Ice that's been partially buried in cement, all right? Then as time passes on, right? As time passes on, the glacier will then begin to melt, right? So as time passes on, as the buried ice is surrounded by cement, eventually that ice will melt and you get what we have here is a geologic feature, right? You have here a lake. So it says, which geologic feature is formed by this process? It is a kettle lake. All right. Ice gets partially buried by sediment, right? Now the ice is fully surrounded by the sediment. The ice melts, and now that hole or that depression that was made from the ice, it gets filled with water. And that's why the correct answer is choice D. The photograph below shows scratched, key word, scratched and polished bedrock produced by weathering and erosion. Scratched and polished. Which agent of erosion most likely carried sediment that scratched and polished this bedrock surface? There's only one agent of erosion that will leave scratches called striations, right? Scratches that are called striations that will leave on bedrock, right? And the only one that has that is a glacier. All right, so that's something that you have to remember. Sediments that's been deposited by a glacier, you'll see scratches on it called striations. It could be polished, and it could also be jagged and angular as well too, as well as unsorted. All right, these are all characteristics of sediments that's been transported by a glacier. Number 14, the block diagram shows a region that has undergone faulting. It says which map shows the stream drainage pattern that will most likely develop on the surface of this region. All right. So if water was to come on top of the surface, where would the water flow? So I'm seeing these gaps right here, which would let me know water definitely flow within these breaking points, right? Within these you could even say it's not necessarily a depression in the land, but basically at these points right in the land where there's more depth, right, where there's spaces for water to flow would definitely be here. And so the pattern that matches that I would have at least two pathways of water to definitely travel matches up with choice C. All right, so once again, imagine if water is pouring down on this landscape, right? How would water flow? That is the drainage pattern that you are matching up with. That's why it's choice C. Number 15 says, based your answers to the following question. Base answer following question on the block diagram below, which represents the landscape features associated with a meandering stream. So that's a key thing. Features associated with a meandering stream. WX is the location of a cross section. Location A indicates a landscape feature. The landscape feature at location A is best described as what? So we know that this is definitely a low level area, right? It's a low level area that's taking place at A. All right, low level area, next to a meandering stream, right? So this low-level area next to a meandering stream, right, definitely is a floodplain. All right, low-level area next to a meandering stream, that'll definitely be a floodplain. All right. And these are right here, right? These are all examples of floodplains. It's areas, right, that's pretty adjacent from the river. It's a low-level area. So all these areas would represent a floodplain. All right, 16 says the diagram below shows four identical columns containing the same amount of water. Four different sized spherical particles made of the same uniform materials are dropped into the columns and settled to the bottom. Which graph best shows the relative settling times of the four particles? So here's what I do know, right? The bigger particles, they settle, right? Or you can say sink, they settle very fast, right? The bigger the particle, the faster it settles, all right? The smaller the particles, right, they settle very slow, right? Which means that it's going to be a long time, right? A long time to settle. And here, bigger particles, they settle fast, which means time is short, okay? So I definitely got to pick one where this bigger shape particle is going to have the lowest time, and this small particle is going to have the longest time. And when I look, the one that has where the big particle has the fastest time, the small one has the longest time, right? And we're seeing that relationship between size and settling time. We're definitely going to look at choice B as my answer. Choice B is my answer. All right, and it makes sense, right? The bigger particles, they take a short amount of time to settle, and the smaller particles take a long time to settle. All right, so that's why the correct answer is choice B. So 17, which geologic evidence best supports the inference that a continental ice sheet once covered most of New York State, right? So this continental ice sheet, right? We also want to look at this as a glacier, right? So when I'm choosing an option, I have to choose an option that's going to resemble evidence of where a glacier used to be, right? So I'm looking at what the sediments look like, right? That's been transported by a glacier, right? What does landscapes look like, right? That shows evidence that a glacier has been here. So V-shaped valleys, that's definitely can be it because V-shaped valleys come from rivers, right? Or streams. Sand and silt beaches. I just see the giant swamps, marine fossils. Nope, can't be that. Basaltic bedrock, folded, faulted, and tilted rock structures. Nope. All right. The fact that I see it says scratched and polished bedrock. We just did a question, right? About a scratched and polished bedrock. And unsorted gravel. Unsorted gravel, right? Deposits. That lets me know if it's unsorted, there's a very good chance it comes from a glacier, and it has the ability to transport even boulders, right? Glaciers have a very good, glaciers definitely have more of a capability to transport boulders than any other agent. And that's why the correct answer is choice B. All right, 18. 18 says the map below shows a bend of a large meandering stream. The arrows show the direction of stream flow. Letters A, B, and C are positions on the stream bed where erosion and deposition data were collected. Which table best represents the location where erosion and deposition are dominant and where an equilibrium exists between the two processes? A check mark represents the dominant process for each letter location. So when I'm looking here, this is what I do know. When I'm looking at A, which is right here, it's on the inside of the curve. What does that mean? That there is definitely more deposition is at A, right? When I'm looking at C, I see it's on the outside of the stream, right? Outside of the curve. That definitely means that there is more what? Erosion at C. And they tell me equilibrium exists between the two processes, right? So more depositions occurring at A, more erosions occurring at B, then that means at C, then that means at B is where we have dynamic equilibrium, all right? Which basically means that there is an equal amount of deposition and erosion taking place. The option that shows that where A has more deposition, B has B has dynamic equilibrium, and C has more erosion is definitely looking like choice. Oh, let me erase this other stuff. Is definitely looking like choice D. You see, erosion is at C, which we checked off. Equilibrium is at B, which we checked off. And more deposition is at A, which we checked off. 19, the map below represents a meandering stream flowing into a lake. A student measures water depths in the stream at 3 locations, A to A prime, B to B prime, and C to C prime. Which set of cross sections best represent the stream bed at the 3 locations? All right. So when I'm taking a look, well, I know the deeper part of the water in the curved part of a stream, the deeper part of the water is definitely going to be on the outside of the curve. So I'm looking at this curve right here. A is on the outside of the curve. So that means A needs to have the deeper part of the water. The water depth has to be deeper. And at B prime is also on the outside of the curve, which lets me know the water level has to be deeper. So water level has to be deeper at A, and the water level has to be deeper at B prime. Now, on this part of the stream that we see here, right, it's not necessarily on a curve, right? This part of the stream right here is actually straight. So that means the deeper part of the river for C to C prime is actually going to be in the middle, right? The deeper part of the stream is going to be actually be deeper in the middle for C to C prime. So which option shows where A is the deeper part, B prime is the deeper part, and in the middle of the C path is going to be the deeper part. When I'm taking a look, it can't be B because it's saying A prime is towards the deeper part of the stream. That's incorrect. It can't be C because it's showing me that between A and A prime, the deeper part is in the middle. And we just acknowledged that A, the side closer to A, is going to have the deeper part. And that's why the correct answer is A, right? Letter A, the deeper part of the stream is closer to A. The B prime, right, is where the deeper part of the water is going to be closest to. And then the middle part, as we said right here, is going to be the deeper part of the stream between C and C prime. That's why A is the correct answer. All right, number 20 says the block diagram below represent caves that develop in a region over time. Which type of weathering was primarily responsible for the development of these caves? All right. So in an earlier part of our lesson, we talked about how caves and caverns were created because of the chemical weathering, right? The chemical weathering that occurred. And what we also said was that anytime that you had the chemical weathering occurred when you had acid rain to come in contact with limestone, right? That's when chemical weathering occurs. So when acid rain comes with limestone, that's when chemical weathering occurs, and that's with choice D. Number 21, it says, base your answer to the following question on the three diagrams below and on your knowledge of earth science. The diagram represents stages in the formation of a large deposition feature formed as a river deposited sediment over time in the ocean. Letter A represents the location in the ocean. State the name of this large deposition feature forming in the ocean. So some key things I see. A river deposited sediment over time. And we know that this is a large depositional feature. All right. So that lets me know, it narrows down a few things. When I'm looking at A and what's occurring over time, doesn't it look fan shaped, right? Especially around here. Doesn't this look like a fan in this area, right? And even here, doesn't this kind of look like a mini fan, like a triangular shaped fan? Well, we know landscapes that look, right, kind of fan shaped, kind of triangular shape in a sense, these are known as deltas, all right? And so this is an example, a picture of a delta. Number 22. So number 2 says, base the answer to the following question on the photograph below and on your knowledge of earth science. The photograph shows a glacier located in the Chugach Mountains of Alaska. I probably pronounced that wrong. Letter A indicates a moraine. Moraine, sorry. The glacier previously flowed down the entire valley. Once again, I'm seeing this word glacier. The lower portion of this valley is now occupied by a stream. Letter B represents the location within the stream. So it says, describe the cross-sectional shape of the valley created by this glacier, right? So we know if we were to if we were to cut this land, right? If we were to cut it in half, what shape would we see? Now, one important thing that we see here is that glaciers create what type of valleys, everybody? It creates U-shaped valleys. Glaciers create U-shaped valleys. It's streams that create V-shaped valleys, right? So U-shaped valleys are created by glaciers. U-shaped valley is the correct answer. That's all that we have for today. All right, everybody have a wonderful, blessed day. Thank you for tuning in. And please make sure that you like and subscribe. For more content, you can definitely look at the channel. Other than that, people, have a wonderful, blessed day. Till next time, peace.